Hello, it's David. Now a few videos ago I built a couple of these external power supplies for my STs so that I could use them a little bit more safely, a little bit more conveniently for me by running a 7-pin DIN power cable to the back of the computer instead of the mains lead that normally goes there, with the power supplies sat in the computer themselves. For me, this makes sense, and it's worked very well. I've been very pleased with it. This one is my Exos power supply, so this supplies +5, +12 across the various pins here, but what it doesn't supply is the -12 rail that the Amiga 500 needs, and I want to run my Amiga 500 off these supplies as well. So what I'm going to do is something that's probably a really terrible idea, and I'll explain why as we go on, but I'm going to fit a little -12 volt boost converter to this pack, supply it on the appropriate pin, and then we'll build an Amiga cable and see how that goes. I actually ran out of mains cable when I built this last time, so it's all a little bit squished in here as well, so I've got some more now, and what I'm going to do is extend this, give a bit more room here, and I'm going to actually add a fuse, or attempt to add a fuse. I've got a 3 amp fuse here. Add this in line. I can't find my 1 amp fuses, otherwise I'd have used those. This, I don't have a hold of this. I shall solder onto the end and heat shrink it all, and it will just provide a little bit of a backup for this supply here. It's time once again for me to mention my friends at PCBWay. Not only are they the one-stop shop for your prototype PCB manufacturing needs, but they also offer CNC machining, sheet metal fabrication, 3D printing, and even injection moulding, all with an easy-to-use web interface. They have a module store, and they host shared community projects too. You can find some of my designs available for download or turnkey manufacture here, for example. Frequently you'll find discounts or vouchers or competitions being run, so if there's really anything you need in the maker realm, why not add PCBWay to your list of potential suppliers? So many thanks to PCBWay, and let's get back to the business in hand. Okay, well, whilst I'm disassembling this, I'll tell you why it's actually a terrible idea what I'm doing. The -12 line in the Amiga is, I believe, basically used for the serial port, but also it is the, oh, that's very tight, it is the negative feed for the audio op-amps. So a lot of traditional op-amps will have a positive and a negative power feed, so that the sine wave, the audio output, can swing both positive and negative. It makes sense. And that 12 volts used for that. So when you take a little tiny switch mode boost converter like this one and put it on an audio line, you're going to get noise because fundamentally it's chop 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 signal. So we'll probably have to fit a big old smoothing capacitor and maybe even an inline resistor on the output. But I'm going to give it a go anyway, and we'll have a listen to the output and see if it's acceptable. The reason why I'm even contemplating it is because I'm not, sorry Amiga music fans, I'm not really all that into the crappy 8-bit digital to analog converter style music of the tracker era. I mean, I've got a Falcon down here, and I've got a Acorn Archimedes under there. If I wanted to do 16-bit era, 32-bit era actually, music, computer music, I would use those. So I'm not really all that bothered by that, but I do want to hear it without it being terribly distorted. So we need to test that when we get there. Right, so first things first, I need to get a bit of mains cable, a bit of longer mains cable than I had before, extend this so I've got some room to work in here with the fuses, crimp on some wires, and I might bring the fly lead out a little bit further as well. So thinking about it, what I might do is actually just put a socket on the end, because I've got plenty of power lead now. I might just, sorry, not a socket, a 13 amp plug on the end. That seems like a good idea. Perhaps the fuse then would be a little bit redundant, but I think there really ought to be an input fuse on here anyway. So what a mess. I think I'll fit that anyway if I can. And what I also noticed is I hadn't put a grounding strap in there when I did that. That was a very temporary, this little thing here was very temporary. I didn't have enough cable at all at the time, and I couldn't route it, I think. I'd forgotten about that. So you see, there we go, always worth double checking. What I was going to say was a good tip when doing anything with mains cable is always cut a nice long amount off here, because it's always easier to trim it down than to get more working cable that you simply don't have access to. Normal disclaimers: any work that you're doing with mains, do not do it if you do not feel that you know what you're doing, that you are not confident, and obviously anything at all related to the fuse box you should leave to a qualified electrician. Public service message. So let's have a look. What we're going to do is we're going to route these through the gland here. This is a 20mm gland. It's actually a waterproof IP, I think it's probably IP65 rated, which obviously is not required for this, but I just happen to have them, and so why not? I've 3D printed a 20mm hole. And what it does is it provides strain relief for us, because you can screw it down tight. So we're going to route that through there. As you saw before, what we've got is a switch with spade connectors on it, and that looks actually like it's a, yeah, I think that's a single, is that, do they call that single throw dual pole? So it switches two things at once. Oops, but it's only off and on. There's no, it's not doing three-way, or two-way I should say. So we could potentially switch the neutral as well, which would improve safety from the point of view of a polarity reverse. So perhaps I'll do that actually. Although I should say that the chances of a polarity reverse on UK 13-amp sockets or 13-amp plugs are very low, especially if you're wiring up yourself. You should know how that works. But you never know, and it doesn't hurt to be safe, does it? So I think what we'll do is we'll get a pair of, see, I've got one, what do you call it, a spade connector on there. Let's put one on the neutral input as well. Will that reach? Yes, I think that'll reach. And then what we'll do is we'll add our fuse in line on the mains side here. We'll get a spade converter on the neutral, and what I'd ideally like, I think, is a ring terminal on the earth there, so that I can put it into the screw going down into the power supply mounting down in the corner there. Now, the way I believe that these spade terminals work, it's not the right, they are called terminals, aren't they? But they're the receptacles, they're not the spade part. I don't know if they've got an appropriate name. Is that the colour doesn't indicate positive and negative, or 5 volts and ground, or anything like that. It is the size of the cable, or of the wire that they are intended to fit. So they're going to all be red, because I've got thin wires here. These ones, I believe, are 1 square millimetre cross section, which is overkill for what we have here. I think half would have been absolutely fine, but that's what I happen to have, so that's what I'm going to be using. There we go. Look, you can see actually it's printed on the crimping tool that those are actually for 1.5 mil square millimetre wire, so it's probably going to be a little bit loose. Need to make sure that we are well crimped. People say do not solder this as well, but I might be half tempted if I can get the boot off, just to make sure that there is no chance of it pulling out, although that does seem pretty sturdy. Quite happy with that. Yep, actually those have crimped very nicely indeed. I'm tempted to whether I should do the -12. No, I think what I'll do, let's get the wiring done first and we'll test it before we worry about experimenting with our -12 volt regulator. There we go. Right, so that's the neutral side being switched up and down that way, and our live side we will deal with in a moment. Let's get the let's try and get a ring connector on the earth there. So we've got ourselves, first of all, let's have a look at this screw. Now obviously we don't have a metal chassis, so I'm not screwing into metal, but I think I still would like to have the earth connected. I suppose technically it's not a requirement, but I would feel more comfortable with it like that. That's quite a loosey-goosey one there. I don't have, you know, those knurled washers that you get for extra, you know, assured connectivity. I don't have one of those, sadly. That will do. There we go. Right, so let's crimp. Let's crimp that one on there. Now I'm not sure if I've talked through this before, but apparently the idea is to leave a little bit of the brush poking out of the top there. I think I'm going to crimp left to right, so try and hold everything in place. There we go. That seems a pretty good connection to me. There we go. So we have an earthed, well that's effectively the ground. So we're tying ground to earth, which can have some negatives down the road, but I think it's probably actually the safest option for us at the moment. Now obviously I could just wire this straight into there and that would work and that would be fine. What I am thinking about doing is inline soldering a 3 amp fuse. This is just a normal household fuse. I actually do have some proper small scale 1 amp fuses somewhere and I cannot find them, but I think that would be probably better suited, truth be told. But we're going to see how this goes. I've never tried soldering onto a fuse before. I believe it should be possible. We'll find out. So we'll give it a good clean. Let me back out there. So we're going to give it a good clean with the IPA. And what we're going to do is to solder this on, well, I'll attempt to solder this on one way, and we'll slip some heat shrink over the top of it. I'm wondering if I should go like this and come in from one side. Do I like that? Yes, I do. I think that'll provide a little bit of strain relief. Then the other one will come in naturally the other side. So let's get some flux on here. Right, this is the most experimental part of the day's proceedings, so let me get you in a bit tighter. This, in fact, I'm going to actually go out of my way and say don't do this. This is almost certainly against some regulation, but I'm going to give it a try. That is a vast quantity of solder, and I'm so far away that my little fume extractor, oh there we go, is not really able to help me out. Okay, let's have a look at our handiwork. Okay, It's not how I imagined that would go, but it has in fact soldered to it. My normal soldering temperature is 290. This 400 business scares me. Okay, there we go. Right, we are back down to 290 on there, and we have, I believe, successfully inserted a fuse there. Okay, so you can see on there quite clearly this says 125 degrees C, so I've got 150 hot air gun here with high airflow, and first of all I'm just going to pinch it in the middle like that. I'm going to work along and inject the air along the tube. Oops, insufficient space, sorry about this, and then there we go, add again at this end, inject air inside the tube, and hopefully that should mould down. Into a nice safe package. One bodged inline fuse. I can hopefully just tuck that safely on the side and connect up to our switch. There we go. Okay, so there we go. I've wired up the mains plug, and as you can see, this is a standard 13 amp UK plug, and it actually has a fuse in it already, which is set. Well, I've installed a 3 amp fuse here, so you might argue that's a little bit pointless adding that one in line as well, but I'm just happier to know that it's there in case anything happens to this plug in the future, or for example somebody were to change that for a 13 amp fuse. You know, it can happen. Right, so we're going to go neutral to neutral, which there may not be anything exposed that I can test with here. Might have to peek down the side. There we go. Okay, so that is neutral to neutral. If we go down to the bottom connection, there we go, we'll throw the switch. There we are, yep. Okay, so we'll try live. We're going to go from the fuse here, live. That should be the top there. That is within the off position. Yep, so that's coming in via the fuse, and that should be disconnected there. And when we throw the switch, there we go, it connects. And there's no short between live and neutral. Yep. And then earth should go all the way through actually to the yep, that's chassis ground over there. Not that there is a chassis, but you know what I mean. That is actually ground on the power supply. Splendid. So, well, the wiring appears to be correct. The next question is, well, does it work, or is it going to blow up? Okay, now I'm being very careful here because we do obviously have mains in the picture, so I'm going to run my ground connection to this screw over in the corner, which is as farthest away from the live that I can make it, and I'm just going to measure on the board. This is the 5 volt output, nothing there. This is ground, nothing there, and this is 12 volts, nothing there. Okay, throw the switch, hope for no bangs. Okay, this is unloaded, so don't be surprised if these voltages are a little bit off. So this is ground, correct. This is 12.31, yep, and this is plus 5.6, as I say, unloaded, and it's dialed a little bit high, I think, because we are running over long extensions going to the computers now. Perfect. Let's give that a try in the real machine. Okay, power LEDs down here. We're connected up. Throw the switch. Okay, we've got a green light. Floppy is yep, there we go. Happy days. Okay, so I've just tacked the module onto the 5 volt and ground line there, and that's what V in and G and D are on the input of this. This is the tiny little module, so we've got V in ground, we've then got an output ground and a V plus, V minus. I'm not sure whether it supplies a 12 volt plus 12 as well as a minus 12 in that case, so we'll give it a measure. That's all I'm going to do here for the time being. We'll give it, first of all, we'll give it a quick measure, open circuit, and then we will we'll put a resistor on it and see what we get there. Emulating, I would say we probably only need about what, 80, 100 milliamps tops, and we can maybe then have a look at the ripple. So what I've got is the STE hooked up to provide some load for the power supply. So I'm going to throw that switch there. Okay, the STE has booted up. Right, so we're going to go from, and this is a bit small just so I can get the multimeter in shot. Right, there's ground, and I'm going to go to V minus, minus 12 on the nose. That's quite impressive. And the plus, V plus is plus 12. Okay, so it provides both rails. So that's interesting. I could potentially actually then just have a beefy 5 volt supply and use a module like this to provide those tiny little extra currents that the hardware needs. But the important thing, of course, is the ripple. Let's have a look at that. Okay, so here is our test setup. We have a 120 ohm resistor across ground and minus 12, which should provide about 100 milliamps of current, which I would imagine is the absolute top end that we would expect to see for a minus 12 volt rail. I may be wrong, but I would have thought if there's nothing particularly heavy on there, we're not going to see much output from that at all. And we've just got that going to the oscilloscope. Okay, so what I'm measuring here is the V min, because we're going to go negative, and the peak to peak, which will be what we look for in the ripple, and we'll add some what's the word? We'll turn it into AC coupling mode when we want to measure that. But I'm just so I've still got the STE connected to provide a base load. I'm going to throw the switch now. Okay, the STE is booting. All right, and we've dropped to minus 11.2. So with a 100 milliamp load, we have lost 1 volt. I think that's fine. Okay, the peak to peak voltage here is jumping around about 600 millivolts to 1 volt, but the resolution here is going to be pretty bad. So let's get the bandwidth limit is on, by the way, to get rid of all the really high frequency stuff. So let's move to AC coupling. Okay, yeah, so there's some pulses rather than spikes. And when we get down in the dirt, to be honest, it's not too bad. It's those occasional spikes, isn't it? Okay, let's see if we can measure the frequency of those. Let's bring the trigger back down. There we go. There we are. A is there, cursor B is there. So 40 milliseconds. Oh, it's underneath. There we go. So that's 24.5 hertz. That is actually, that's in the audio range, isn't it? That is at the high end, the absolute top end of audio range. So that could manifest as a whine potentially. Okay, so I've only got one of these Amiga power connectors currently on this ATX adapter that I built, but I think what we'll do is we'll reclaim this, and what I propose to do is to just make a little stub connector. So I'm going to wire it up to this 7-pin DIN socket, and we'll have our normal straight through 7 to 7 cable that plugs into this and then just has the Amiga socket on the end. Save me having to build up another lead, which I probably will do in the future, but I just want to get some testing done. Okay, so this is what I've knocked up off camera. You've seen me solder these up before. It's not a pretty sight, there's no point in me showing you that again, and we need to run a couple of tests on that. So before I do that, I'll just show you what I've knocked up here. So here's our module. This is still on these long flies for now. So this is the 5 volt on the ground going in, and what I've done on the output stage here, this is the plus 12 we're not using. The midpoint is the ground, and then we've got the minus 12 over here. So I've got two parallel 10 ohm resistors there to provide 5 ohms in series, and then I've got a 10 microfarad capacitor, electrolytic capacitor, across the output stage there. Bear in mind that's the negative lead, that's the cathode. That's actually going to the -12, obviously. That's the other way around to how you normally have a low pass filter. And the positive side is going to ground. So obviously because we've got a negative voltage, there's no ground line coming out of here because it's common ground. And all I've done is I've routed that over here, and that is attached to the appropriate pin on the 7-pin DIN up there. Okay, so I think it's time for a test. So we've got this hooked up. The new power adapter there is just going into the back of the A500. We've got the monitor and the significantly the audio cables in. It's not going to a very good speaker, I'm afraid. It's just the one built into my old monitor here, which is currently set up with an HDMI adapter. There we go, showing no signal at the moment. And we will throw the switch and give it a go. So Amiga will flash the power LED, I believe, here if anything goes wrong. So we're going to keep an eye on this at first and see what comes up on the screen. So there's our -12 volt line. I'll take it off and do some measurements if this works. Okay, yeah, we've got white screen. That's, yeah, it's gone for the drive. It's gone for the drive. There we go. And it's loaded up Amiga test kit, which is the last thing I had on my Gotek stick here. So perfect. Audio's F5. I don't know if that's coming across. Just got my microphone over there by it. That's all channels off. All channels off. Channel 1. Adding channel 2. That channel 2 right there, that sounds actually quite noisy to me. But that may be how it's meant to be. Like I said, it's only 8-bit audio, isn't it? Well, that all sounds pretty good. What about with the filter F6? Yep, well, I don't know how well that comes across, but I could definitely hear that. So let's switch to 500 Hz sine wave. I don't hear any distortion there at all, to be honest. That sounds perfect to me. Right, well, I'll be honest, to my ear and these crappy speakers, that sounded absolutely fine. Okay, so first things first, I'm just going to measure the power dissipation across those 5 ohm resistors to make sure that we're not about to cause some kind of heat meltdown. So we've got no audio playing at the moment. This is on. No audio playing at the moment, and we've got ground connected here on one side of the resistor pack and on the other side. And there we go, I'm measuring 100 millivolts DC. There we go, I've got the music on in the background now. I don't know if you can hear that from my lav mic, but let's try that again. So we're going to measure the DC across there. Okay, it's gone up to 155. Okay, so the power dissipation across those resistors is a square root of bugger all. Let's see what it's done to the noise. Okay, well, given the results we've already seen, or rather heard, I'm not going to bother cracking open the A500 to measure on the inside. So I'm tapping here at the point at the end of the cable just before it enters the Amiga, and we have that running now. Let's put the music on. Okay, we've got the music running in the background, and we can see that we're showing approximately There we go. Jiggling around a bit, but minus 11 volts. And you can see that there is actually noise still on the line even after my bandpass filter, so to be honest that hasn't had as much of an effect as I would have liked it to have done. Right, anyway, I'm going to have a quick look to see what sort of figures we're dealing with here. So we're going to AC, kind of center that to ground, and we're going to zoom all the way down. Yeah, we are still getting quite substantial pulses there. You know what? I may have made it worse by introducing that 5 ohm resistance. Every time that the Amiga tries to draw from that power line when the signal goes negative, it's entirely possible that there's a voltage, there's an effective, well, voltage increase because it's negative, but you know, an actual potential difference drop. Effectively, well, it's not ground bounce. No, it's voltage. It's power line droop. That's potentially what I've done here. So that could be an absolute bit of a backfire on my part. No, that's roughly the same, isn't it? That's sort of 20. Oh no, sorry, that's 20 hertz. 25 hertz. I mean, that's mains buzz territory. Could this just be outside noise because we are actually now running an Amiga, whereas previously we were just testing with a dummy load? That's interesting. I think I should put the dummy load back on. Okay, well this seems pretty conclusive. So what I've got is just the dummy load, the same resistor as before actually, across the -12 and ground line there. And when we look at the oscilloscope, sure enough, between pulses on here we see about 25 hertz. So I think that's a very good chance that is mains hum, and the reason that I say that is because we're not actually even plugged in at the moment. This is, I think, just picking up background. So why don't we plug in and throw the switch and see what changes. Well, as I rather hoped actually, the noise has gone well down. Yeah, we're not triggering at all at that level anymore. Let's take out the, there we go. Okay, so we are still seeing the same spikes. There they are, but we've had to go down to the 200 millivolt level. You know, I'd have to go back in my video and double check that I didn't get the unit completely wrong and we were just looking at 25 hertz from the get-go, in which case yes, I'll feel somewhat foolish, and it's exactly that 25 hertz again there. So there we go. You know what, I can see that there's, you know, has the potential for adding a little bit of supply line droop, but I'm happy with that. I'm going to leave that, I think, as it is. So in the end, I didn't trim down and resolder those wires because they're just about the right length to allow me to wrap around the back side of the power supply and come out at the connector up here. So all the heat shrink's now done, and there's a nice blank spot just above the toroidal transformer up here where I was able to lay down some hot glue and stick that down. So I think that is actually pretty much done. So I'm going to reassemble that, and we'll fire it up with the A500, and I'll see if I can get some direct audio capture for you to see what you think about the quality there. And yeah, Bernie, don't do that. So there we go. So that module turned out to be quite capable of supplying minus 12 volts. I can't detect any audio issues at all. The ripple wasn't really a thing. I was trying to suppress a whine that wasn't there. It was simply that I had misidentified the frequency in my my initial inspection, and I think this would have worked absolutely fine without that filter in place. I don't think it hurts to have that filter, but I think that has nothing to do with it. That those pulses that we saw on the oscilloscope there, I am convinced is just background noise from my electronically noisy shed, but the way I can tell that is if you disconnect it from the power supply, they're still there. So that was a complete wild goose chase. The fuse that we fitted, that's complete overkill and not the right way to do that. Obviously, you know, an inline fuse holder is the way forward, and ideally I'd like probably a 1 amp fuse, but the 3 amp there, it's better than nothing. I'm happier to have it than to not. So I think I am actually genuinely very happy with that result. I suspect that actually the plus 12 would also be good enough, given that well, most people these days aren't running physical floppy disks or physical hard disks. It probably would be enough for a floppy disk as well, actually, because I think certainly a lot of the later ones didn't actually require the 12 volt line. I think hard disks tended to, but if you're not running a physical one of those, then I suspect the plus 12 only really services, again, the other half of the audio circuit and the RS-232, which is absolutely no current demand whatsoever. So that might bring into play the smaller Meanwell or other industrial power supplies that you can get, and then just a little module like that to do the two 12 volt rails, the plus and the minus. Heck, you could probably even fit that module inside the Amiga itself and then have just a 5 volt supply. All you need to do is to make sure you tap the rails at an appropriate place. A lot easier on the ST, of course, because you actually have a cable that you can simply hack into. So I think I might get another one of those modules and do the same conversion to my other power supply, that is the Meanwell one, and then that would let me run all of my STs, my Amiga, my Archimedes, although the Archimedes has got its built-in, actually, you know, it doesn't have an IEC plug on the back, it actually just has a cable on the back, so I'm unlikely to change that one, I think. But I could run them all then from the two suppliers, and they would be interchangeable. Anyway, thank you very much for watching today. It's certainly been educational for me, and I hope it has been vaguely interesting to anyone considering one of those little 12 volt modules. See you in the next one.